Hey everybody. So quick video here. After the last video about probability-based patterns with subdiv tilde, I realized that this object makes it really easy and fun for us to talk about the idea of polyrhythms versus polymeters, explain what exactly that is, and show you how to implement them in Max. So let's do that. This that I have in front of me is a simple patch that's just demonstrating the concept of a polyrhythm. So what distinguishes it that way is that we have a single bar, which is sort of a global bar that's feeding into two subdiv objects. One that is dividing the bar into increments of 4, and another one that's dividing it into increments of 6. So over the course of this one phasor's ramp from 0 to 1, we're going to get 4 impulses out of this set of objects on the right, and we're going to get 6 impulses out of this set of objects on the right and the left. I think I mixed those up. So the amount of time that it takes to get from the first to the end is the same, but in this case we're going from 1 to 4, and in this case we're going from 1 to 6. And if I put these side by side, you can see that this one is moving. Perhaps you could see this one is moving quicker. I think it's easier to see here, right, that the gaps just between those different impulses is more on this left side than it is on the right side. So that's polyrhythm. Polymeter, which I'll show you, is different. With polymeter, the gaps between the impulses would be the same on the left and the right sides, but the counter would be different. The counter would go still on this side from 1 to 4 and on this side from 1 to 6, but they would do so at the same with the same amount of space in between each event. So let's go look at that. So I'll explain the patching, but just to get ourselves started. Looks like it isn't doing what I expected it to do. There we go. So we can see here that the spaces on the right side are the same distance as the spaces on the left side, but that this one counts to 6 and this one counts to 4. And if I reset the counters so that they start from 0 at the same time, you can see they count together until they go off. So when this one is going to, I believe it's 5, then this one goes back down to 1. So how do we do that? The bottom of the patch is, except for this part, so this part is the same as what we had before. And this very top part is the same, except for this. So it's really the middle here. That's the new stuff. And what we're doing is changing the length of the input bar before it hits each of these subdiv objects. So in this case, we have 4 steps that we want subdiv to produce. And we're going to say that for the entire patch, there's a global subdivision of this main global bar that is 4. And so we're going to say for this one on the left, okay, give me 4 steps at a subdivision of 4, which means that the phasor is going to remain the exact same length, and we're going to get, in fact, the same result as we did in the prior patch, in the polyrhythm patch. On the right-hand side, though, what we're going to ask it to do is give us 4 subdivisions of the main bar. So give us steps at the length of 4 subdivisions of the main bar. But give us 6 of those. So the way that we do that is we use, inside this stretch bar abstraction, a rate object. And all rate does, it's pretty simple, is scale the length of a ramp using a floating point number. So there's a good example over here. If I set this to 1, you'll see that I have a phasor sending its output into a rate object, and the output of each of them is exactly the same. But if I change this value to say 1.8, you can see that the phasor that's coming out of the rate object is taking longer, right? If I set it to 0.5, I can make it shorter. And you can also see what's interesting is that when I make that change, it can go out of sync. And I think that there's a way with an argument to, sync. Do I want cycle or do I want lock? Let's find out. So if I say 1.6, I think I want lock. Yeah. So this sync attribute helps us basically to control what happens and how these two phasors relate to one another when I change the rate. But the point is that the rate object is capable of basically scaling phasors and making them either shorter or longer. And so that's what we do here. We basically say, take this phasor that is running at 1 bar according to the global transport, and now make it run basically at 1.5 bars. And then over that time period, we're going to produce impulses. We're going to produce 6 impulses of that new bar, which is going to give us events that are even the same spacing as the left side patch. But we're going to get 6 of them over the course of this new bar on the right side. So what we did was we added that rate object abstraction in the middle. And the way that we got that number, by the way, is we just took the subdivision, the global subdivision, and the steps, and we divided the steps by the global subdivision, and we passed that into the right inlet of the rate object. So in this case, 6 over 4 is 1.5. And then we have this what object, which is just a counter resetter, right? So this one, all it's responsible for doing is emitting an impulse at the end of whatever phasor it's receiving, which in this case are these 2 rate modified bars, which causes our accumulator, our plus equals tilde object here to start counting again, to start counting from 0. So this approach of polymeters, typically when people are talking about polyrhythms, they're usually actually talking about this. This tends to result in somewhat more like musical rhythms. If you look at a step sequencer or any kind of gear, you're usually seeing rhythmic increments that are like 4, 16, 8, 32, right? Things that are multiples of one another. Or you're operating in the realm of triplets, right? So 3, 9, 12, those sorts of things. If you start to mix and match those things, like 3, 9, and 12 with 4, 8, and 16, then you're going to end up with stuff that's weird because you're going to have events. For example, if you're using 3 and 4, you're going to have events that are happening in between the period of the other sequence, which might be something that you want. But is definitely more unusual. And that's the kind of stuff that really falls into the domain here of polyrhythms rather than polymeters, where you always know that you're going to be kind of working with the same basic subdivision of the master bar. And that may be, it may be that you scale up to different multiples of that subdivision, like 8 or 16 rather than 4, or down to 2. But you're not going to move to any type of subdivision that is not a clean multiple of the others. So that's the difference between those two. Let me know if you have any questions in the comments. And if you are working on anything that uses these concepts, please let me know. And if you also have other ways of implementing these things in Max, also let me know, because I know almost certainly that there's other ways to get to the same result. So that's always cool to see. So share that. Okay, thanks. Happy patching.